How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com.
Hey, Carl and Richard here. As you may have heard, NDC is back, offering their incredible in-person conferences around the world, and we'd like to tell you about them.
NDC Oslo will be May 21st through the 25th. Go to ndcoslo.com to register.
NDC Copenhagen is happening August 27th through the 31st. The early bird discount for NDC Copenhagen ends June 2nd. Go to ndccopenhagen.com for more information.
NDC Porto is happening October 16th through the 20th. The early bird discount for NDC Porto ends July 21st. Go to ndcporto.com to register.
And check out the full lineup of conferences at ndcconferences.com. Hey, guess what? It's .NET Rocks. I'm Carl Franklin.
And I'm Richard Campbell.
And this is the beginning of a long run over a few days of show recordings that we have to get in the can because we're going to be busy.
We're going to be traveling again. And so it's good to sort of organize it. I think I said to you in between recordings last week, because we were just doing like a show or here or there, just staying a week or so ahead. It's like, I'm going to load up a bit. We'll see what happens here. I've got a few emails going out. And then in fairly short order, I kind of said, hey, sorry, this is a lot of shows, but it's also fun.
Yeah, sure is.
To just sort of focus and have intense conversations about great technology. So I'm really looking forward to this flurry. And then we'll be doing some on-stage and live shows and in-person shows coming into spring conferences.
That's right. At Techorama for one.
Yep. Techorama will be one of them.
Yeah. And when is Dev Intersection again?
The next Dev Intersection is the first week of December in Orlando.
Ah, that's going to be fun.
So we're going back to Orlando. We're in the Swan. And the registration's opening up shortly. Still working on some curriculum and stuff, but we got some time. I got some crazy keynotes because you think about how much has happened since ChatGPT in November.
Oh, I know. Yeah. Crazy.
And here we are in April. Now think about what it's going to be like by the end of the year.
It's going to be insane. I mean, it already is insane.
I don't know. It could go either way. This is quite the hype cycle.
Yeah. Well, let's get things started with a little thing we call Better Know, a framework.
Awesome.
All
right, man. What do you got?
Speaking of ChatGPT and all that great stuff.
And hype cycle.
And the hype cycle. And the hype never ends. Everybody's jumping on the hype bandwagon here. Google announces AI features in Gmail, Docs, and more to rival Microsoft. This is an article in The Verge, March 30th. Google will soon offer ways to generate text and images using machine learning in its workspace products as part of a scramble to catch up with rivals in the new AI race.
Right.
Yeah.
This is the logical hit back, right?
Of course.
Because Microsoft goes after search with Bing AI, so Google goes after Office with features in Google Docs, Sheets, etc. Because that's one of the few places that Google can really scare Microsoft, right?
Yeah,
One would argue everything that happened in Office 365, now M365, was about competing with Google's Docs online.
Google Docs. Yeah. I use it all the time.
Yeah.
Just because it's easy.
Well, I think about the number of times you and I have been writing simultaneously in a Google Doc for like an ad script or any of those sorts of things.
And I even use that feature in our admin app.
Yeah, that same effect.
It's good old Signal R, man.
Yeah. The thing that interests me is this like Bard? Is this a forever beta?
I don't know. Gmail was beta forever, wasn't it?
Yeah, for 6 years, 7 years, like
6 years. Yeah, crazy.
I get that they're responding. It's the question is when are you going to release it? Because I'm in Canada. You can't use Bard in Canada. Can't even take it out for a spin.
I got to tell you, I was talking to one of my customers just a few days ago, and he said boy, I tell you what, man, ChatGPT is just saving my butt, saving so much time, for little syntactical things like how do I do this? How do I do that? Yeah, it's pretty good. Just make sure that you test it thoroughly.
It's actually correct. And the question is that special to ChatGPT, or if he'd bought Grammarly, would he have gotten the same thing?
Oh, I don't think Grammarly can do link queries, but certainly ChatGPT can. Yeah.
Yeah, that's true. If he's writing code versus writing copy.
Yeah. Code. It's really great for code.
Yeah.
You just got to make sure that, it's good.
Is it better than GitHub Copilot?
Yeah, I don't know. Man, what a great comparison to do.
Yeah.
We ought to do that.
There's so many, believe me. And I don't want to make this the all large language model show.
No. This is just the intro here.
There's lots to talk about.
Roni's coming right up here. But before we bring him on, who's talking to us, Richard?
Grabbed a comment off of show 1790. That's the one we did with Chris Klug when we were talking about his experiences, doing experiments with different infrastructure as code solutions, Terraform and Bicep and Pulumi. And of course that ended up in a conversation about the DevOps cycle as a whole, automating of builds and so on.
Yeah.
Which is really, part and parcel with trying to make your software better. And Devin Goble had this great comment. This is from last year. He said, my hot take on DevOps is that too many practitioners start off with rigid, preconceived notions of what they want to do. This is normal. Our decision making is always going to be shaped by our scars. We've used that line before.
Oh, yeah. Old pain. That's my favorite. Yeah.
However, it helps to approach DevOps technology like any technology with an open mind. Start by looking at whether or not the out-of-box functionality is sufficient, and if not, why.
Yeah.
We always tend to want to mold the tools to our vision of what it's going to be rather than just use what's there. And here's a line that I love. Are the scars running the show?
Wow.
There's always going to be some amount of custom work that needs to be done, but our first step is always start figuring out how to get the pipeline to run a custom bash or PowerShell script. You're probably doing something wrong. You aren't that special. If the canned features can get you most, if not all the way there, you should start with those. They almost always are going to provide decent error handling, logging, and parameter checking, especially if they're first-party offerings. Keep in mind that there are going to be differences between greenfield and lift and shift that might require some extra work. I like to think this way in any cloud project. If step one is to create an Azure VM and install SQL Server, you're probably doing it wrong.
Yeah, probably.
Devin's gotten, I checked back and saw we've exchanged a few emails before. He's received, Music to Code by before, but Devin, such a great comment, man. So thanks so much for commenting. And if you'd like a copy of Music to Code by, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if we comment there and I read it on the show, we'll send you a copy of Music to Code by.
And, you can follow us on Twitter, but we'd really like you to follow us on Mastodon. I'm at Carl Franklin at techhub.social.
And I'm Rich Campbell at mastodon.social.
And send us a toot. We'd like to see you there. My tutors are growing. Let me say that. Yeah.
Can you say that? Is that?
I don't know.
Do you need to bleep that?
No, I don't think so. Tutors, man.
Your tutors.
My minions of tutors.
They're
just
followers like everything else.
I started this just a couple months ago, maybe, and got about 1,200 followers now. So that's really good. And I always follow whoever follows me. That's just the way it goes. Well, anyway, let's bring on Roni. Roni Dover is a holistic developer and builder with a passion for development processes and practices. Afflicted by an acute product manager/developer split personality disorder that was never treated.
Is there a cream for that? I don't think there is.
I don't think so. You got to go into the office. Currently CTO and co-founder of Digma, Digma.ai, an IDE plugin for code runtime AI analysis to help accelerate development in complex code bases. A big believer in evidence-based development and proponent of continuous feedback in all aspects of software engineering. Welcome, Roni.
Hello. Great to be here.
When I hear continuous feedback, that's one of the features of being in a state of flow, isn't it? Yeah, we heard about this great book, Flow, by Mihai Csikszentmihalyi from Mark Seaman many years ago. And, they talked about people filleting fish, all day long at the market, Pike's Market, the guys who are just like filleting salmon, and they're just in the zone. But that state of flow gives you this continuous feedback, and that really allows you to go fast.
Yeah. And maybe before I dive right into it, I just want to touch on your previous discussion about AI and AI systems.
Oh, sure.
Because I was just having a casual conversation with a friend, and we were trying to estimate just how much code exists today in production systems that was written by AI, and maybe nobody even took a look at it. Like no human intervention. And you could say the same about Stack Overflow, or they said back then to copy paste that type of development. But the more abstract the AI, and I'm a big proponent of AI, and I'm using it a lot myself, but the more you kind of abstract the request from the AI and kind of remove yourself from the generated code, it becomes less about snippets or regular expressions or link queries, and you can actually request entire business logic being implemented.
That's right.
And that's amazing to me. And to me, it's also very poignant and relevant to the topic of feedback, because essentially you have a bit of code here, and it doesn't matter if somebody else wrote it or I wrote it a year ago, or maybe I'm just kind of trying to make to make kind of this opaque piece of code a little more transparent to me. And it seems like without that type of visibility, we kind of have a problem on our hands. And it's the kind of problem that you don't notice until you do. And we were kind of chatting before, and you guys said that over 20 years you're on the air, which is amazing. And I've been a developer for more than 20 years. And when I got started, at least in the culture of the organizations that I worked around, there was no continuous testing. And I remember it very well. And it was, that's what we knew. There was some testing that you had out of the kindness of your hearts to run every now and then, but that was just about it.
Hopefully you had testers or some sort of QA in your organization.
Yeah, or a QA department.
Yeah.
But essentially...
But that's not continuous, right? They're still taking a bite and
you're
running
right.
it. Like it comes down to how do you describe continuous? Like I would argue that IntelliSense is continuous.
For sure. So essentially I was, we were kind of running blind. Like, today for me, like pushing changes without running tests is, you must be a very brave and I don't know,
Billy Hollis,
desperate soul to actually do something like that. But it's crazy.
Yeah.
Or so it seems today. And at the same time, once kind of you start understanding that feedback is really essential. Coding without feedback, I kind of feel the same type of blindness.
Yeah.
That I felt when there was no kind of infrastructure of tests to support me.
So what do you mean when you say feedback? Like what are you looking for?
Sure. So essentially today we're pushing code, we're running code, and that code, especially with recent kind of leaps in observability technology, has a lot to say about how it's functioning and how it's running. Mm-hmm. There is a lot of data there. The question is, are we looking at that data, and when are we looking at that data? So let's say I just I pushed an upgrade to the DAL system, like to the DAL layer, data access. I added some caching and some other features around it. I was shocked how many developers, when given such a feature to develop, would go ahead, develop the feature, maybe run a few tests, deploy it, and that's it. Move on to the next feature. Mm-hmm. Without, for example, examining, did it make life better for everyone? Did it improve the state of the system? And there are many reasons for that. And, I just give one example, but, I could look at numerous cases. And this is something I noticed while working alongside with very talented developers. And they were given a feature. They developed it. They wrote the test. They did everything. Today, they even wrote the Helm file or the Terraform to deploy it.
Mm-hmm.
They pushed that merge to master button, and then they moved on to the next feature. And I asked them, is your code even getting executed in production? Can you tell me even that? Maybe you made maybe there's one bad if statement preventing your code from ever being run.
I mean, presumably you even described it this way. They ran it themselves, right? You write some code, you run it. Like,
sure.
There's your feedback. The compiler compiled it and it showed up on the screen, or it showed up in some, in some way. But I think your point of now you push it out, put it into the pipeline and it goes out into production. When's the next time those lines of code get executed? Exactly.
And, this is something that's been bugging me. And you're right that there is some information that you get out of, let's say, your dev system, and maybe some feedback you get back from the test, which is mostly kind of limited because it's not qualitative. It's more true, false, pass, fail kind of thing. But when it comes to more non-functional feedback and more kind of feedback that has to do with the quality of the code and the impact of your changes, there's very little of that, both from CI and production and even in dev. And I'll tell you another story. I caught a developer in my team adding a console log statement to a background service. And I noticed it because I'm looking at my code and I'm seeing it was just printing the amount of time that kind of loop iteration took.
And you were running your code that happened to call his code, and now you're seeing stuff show up in your console.
Exactly. Now, first of all, I would like to commend that developer, because a lot of developers would not do that, right? They would not even check for that. It shows that he had the kind of insight to say, this is important to notice as I'm making changes. Did this kind of, did this cycle increase dramatically in terms of performance? Why? Because, maybe I made a mistake. It's the wrong technology to do it.
Yeah.
Like, probably a console log will kind of, he'd probably not notice it forever, and it doesn't become a part of his dev methodologies beyond just that one time that he added that.
Console log is the debug tool for JavaScript, isn't it?
Exactly.
Yeah.
But at the same time, I completely sympathized with the sentiment, and I wanted, without thinking about adding a console log, for that information to be very, as we said before, continuous and proactive, so that I don't need to think about it immediately because my code is running, because I made some changes, and because things are now worse or even better. Like, I like to get positive feedback as well. That feedback will start streaming to me as a developer, and that becomes kind of my eyes and ears about how my code is running and whether it's running. And again, what is the impact of my changes?
So it's part of what you're saying there reminded me of, this is stuff we catch in code review, that if you're pair programming or if you do a code review, like, I don't know of any other way that really assesses code quality other than other pairs of eyes on it saying, there's a more reliable way to write this, that kind of mentality of just like making higher quality code. Because a lot of developers are still very much in the place of, hey, you know what? It runs. Like, that's good enough. There's no concern about quality. The main quality is it functions.
Exactly.
So did this issue ultimately lead you to Digma? And,
yes, exactly.
And did you look for other tools out there? You said there isn't anything out there that does it, but what does Digma do that's so different from, other telemetry products, let's say?
So actually the origin story is that I was looking at the DevOps loop, a diagram that's by now become, completely overused, misused, whatever you pour in it, but it's still kind of a good model of the process. And I was noticing in that particular diagram I was looking at, it had like different tools associated with each step. It was kind of like an ecosystem breakdown. So you saw a lot of build tools, deploy tools, continuous integration tools. And there was actually an arrow leading in the other direction. There was an arrow leading from production back into dev, and it said continuous feedback. That's what the name said.
Mm-hmm.
Yes.
And there were no tools associated with that particular error. And that kind of blew me off because I was looking at this diagram and there's so many CI tools, so many build and deploy tools, so many monitoring tools. All of these exist. How come when you looked at continuous feedback, what was supposed to bring the information back to the developer?
Now, we could talk in terms of, was that feedback supposed to go back to the developer? Or is that feedback supposed to go back to the PMs? As this is how features were used. Here are the errors that we're seeing. And then it gets fed into the sprint pipeline as remediations, and people aren't using this the way we thought, that kind of thing. Like there is tools in that space.
Yeah, there are telemetry tools.
Yeah, you're right. But I think that we need to separate the types of feedback.
Mm-hmm.
And as I was saying before, and you actually mentioned it in the most accurate intro that was ever actually written about me, that I have a split personality between being a product manager and a coder.
Yeah.
And putting on my product manager hat for a second, there were great tools as a product manager to understand what my users are doing. So from a product perspective, I have, the analytics, the tools that give me feedback about how the product is doing. From a developer perspective, there is no Google Analytics for developers. I don't know which parts of my code are being used and how, and I don't understand that this specific area of the code is a major nexus bottleneck area that is being used by multiple flows in the system, that the routing so much traffic, and I need to think about concurrency here. It kind of becomes tribal knowledge. So, if anything, I think there is a big gap between the kind of elegance and richness of the ecosystem available to product managers and the technical feedback that I want to receive, both as requirements and as kind of a feedback back on my work that's available from a technical perspective to developers.
So Raygun doesn't do that, for example? I'm just thinking off the top of my head. You can't tell Raygun to analyze bottlenecks and report back to me timings and things like that?
Sure. There are a lot of technologies, but what I found out when I talked to developers is that continuous feedback is not something they practice. Meaning, when you talk to most developers, although there are many dashboards and many kind of nice ways to visualize the data, and to be frank, this caught me so off guard as a developer that I spent half a year just researching this. And by researching, I just meant talking to as many people as I could and
right.
Trying to get to the root of the problem. And I found out two very simple things. First of all, developers are busy, mostly overworked, and they don't go looking for trouble. This is why developers didn't write tests out of the kindness of their heart.
Yeah.
Unless it became continuous and it became something that had to happen. And in the same way, developers won't go looking for trouble in the dashboard if it means another kind of headache that they need to fix.
Right. You work your burn down chart.
Uh-huh.
And if you've got somebody enforcing code coverage, then you do enough code coverage to keep you out of trouble.
That is such a true statement there. Developers don't go looking for trouble. So talk about security. Like, we don't like security. That's just telling me what I can't do. We don't like somebody telling us, oh, this code could be improved if you just did this and that. And you're like, yeah, I'll get around to that. Shut up. You got a little fragile ego.
Well, mostly because I benefit from shipping features.
Yeah, right. But we've said this before on the show many times, Richard. If you want to be a good developer, lose your ego, right? Because it's all about having the best code and having tools that point out, this could be better. It's actually making you a better programmer and making your products better.
For sure.
So yeah, truer words were never spoken. Developers don't like to go looking for trouble.
And by the way, I completely share that sentiment. When I stop talking on podcasts and I start coding, it's the same thing. I feel I like moving forward to the next new feature. I like kind of a feeling progress, and if I get sucked into these issues, then it just slows me down, and I'm subconsciously motivated to kind of not necessarily invest in these areas, and this is a problem, and it also requires cognitive effort, and this is the other thing that I noticed. So to get to some of these realizations, like, you know what, as of my last commit, this and this change, this timeout error rate is different than it was before in this API that I'm using or whatnot.
Right.
I need to have some cognitive effort and tools and expertise that not a lot of developers have. And as a result, my statistics 101 is pretty kind of not as up to date. And many developers kind of try to ignore it because it's not in their comfort zone, not something that they know and practice every day. And that makes a lot of sense too. That's why we have tools.
You talk about cognitive effort.
Yep.
It's when you have that typical DevOps feedback cycle that lands back on the PMs and the feature designers, the business analysts and so forth. The way it trickles back to the developer is, the app's too slow. Like, that's some cognitive effort, like, to try and address that problem. Say, okay, well, where is it too slow? How is it too slow? Like, to just decompose these sorts of broad statements into actionable code. That's a lot of effort. You can spend a long time trying to break that down enough to go, this is the piece of code we need to optimize.
You're absolutely right. And time is key here, because if it takes a long cycle, you lose context of what you were doing. You're context switching. There is this issue, but now it goes back, need more information. And then DevOps guys weigh in, and then the IT guys weigh in, and you go back to the customer, and eventually kind of it becomes a very inefficient process.
So how does Digma address this issue?
Yeah, so the premise of Digma was very simple. It was all of the information is there. The problem is making it proactive and reducing the cognitive effort and making it something that's continuous, that fits into my dev workflow. And if we can use AI to generate code, there is no way we can't use AI to evaluate the code at runtime. And essentially what Digma is a way to, is a platform that evaluates the code in runtime, and kind of like a linter maybe, but not for static analysis, for dynamic analysis. And it can give you that indication straight away in dev, then in test, and in production, about specific issues that you should notice in your code, specific parameters that you need to know in order to better design it. And the concept is that we didn't invent a profiler. We didn't, have to add some weird reflection into the code to make it happen. We just used the existing technologies, and actually .NET made it amazingly easy by incorporating OTel into the standard library as a part of system diagnostics, which, to me as a .NET developer was great news, because it just made it a lot easier to support it within .NET.
So what's built into .NET that makes your life easier?
So as of .NET, I think it's 4.68. They added it backwards or something like that. The system diagnostics now supports OpenTelemetry.
Right.
OpenTelemetry, for those who are not familiar with it, is a great step forward with observability. And the reason is not that it's doing anything groundbreaking, but that everybody agrees on it,
right? And
it's open source.
It's standard.
So the combination of these two, it's understated here, but it really becomes a game changer in terms of observability, because suddenly, you can rely on an open standard, and you don't need to kind of support one APM or another APM and their proprietary kind of finicky abstraction, but you have this open source that's, by the way, very staggeringly popular across different platforms and languages. Java, Node.js, .NET. You can be a polyglot developer and kind of benefit from it across your distributed microservices in multiple languages. And it's open and very easy to kind of create an ecosystem around it. And because it's so widely agreed upon, support started kind of becoming a standard for any library or platform. So ASP.NET MVC natively supports it. You don't need to do anything. You just need to turn it on. It's an on switch.
Wow.
If you're using any framework, it supports it. If you're using an adapter for Postgres, it probably supports it. If you're using mass transit to work with RabbitMQ or something like that, it supports it. So that means that taking a project from having zero visibility about what it does in terms of traces, metrics, and logs to having almost too much data is a matter of flipping a switch rather than kind of, let's kind of think about it, create a project, philosophize for like 2 months about what we want to capture, then implement them, let the infrastructure team work on some infrastructure for that. No, it's already kind of out of the box. And that's a big game changer that makes technologies like what we're doing with Digma very easy, because now we have the data, very easy for the user to turn it on. And then it's just a matter of how do we process it and make it relevant. And to make it relevant, we understood that our front end needs to be not a nice dashboard, but the developer's tooling, which is the IDE, the GitOps process. This is where he'll need that information. And so it becomes this kind of a living documentation and something that kind of becomes embedded within the code. So that I kind of take even that cognitive effort of opening another tab in my browser and looking up a dashboard just because I thought I should check. Instead, it becomes something that, just like a linter, becomes embedded in my tool.
Well, now that you've completely piqued our interest, we're going to pause for this very important message or two. We'll be right back. And we're back. We're talking to Roni about Digma. And now that we know what it is, and apparently that you just have to turn it on and magic happens, is it really that easy?
Yes, and but I can take no credit for that. The open telemetry and OpenTelemetry and how easy it is to integrate with .NET was a very strategic decision by the .NET team. And there are, so many different examples online. It is that easy to get some data out of your application, and there is also so much more depth to that data, because now it's not just about logs, it's about logs and metrics and traces and intercorrelating them. So it's very, very easy to get very rich data and start making evidence-based decisions about your code and knowing what to focus on and what you need to improve. And it can seep back to their product managers who now know that they need to prioritize something because they know its impact.
Give me a typical example of something that a developer might do that Digma would pick up on and say, hey, you should do it this way instead.
Sure. I'll give you a few. One example that I noticed is, especially working with entity framework and these kind of abstractions, is you often fall into some code smells inadvertently just because of leaky abstractions and such, where you might create, let's say, an N+1 query or some kind of inefficient query that can be picked up if we analyzed what was actually happening when you run it. And this is something that's easily picked up. Like if you look at the trace, it will immediately jump at you. But to look at it and to know how to do that is another thing.
Right.
And it could be something that has to do with basically how, let's say, how the code is being used. So let's say I want to make a change in a particular area and I'm working in a complex environment. So finding static usages is one thing, but understanding who's using this code in runtime is another. And why is that important? Because those are the areas I want to test, that I didn't break their flows, I didn't break their APIs, and so on. So this is from a usage perspective.
Well, and that's ultimately what matters. It's not what you thought they were going to query from the data. It's what they queried from the data.
Yeah.
Exactly.
You're taking in a parameter from a user and they're searching on something horrible, but that's what they're searching on. So, how are you going to deal with this?
On top of that, the entity framework context could be described as a wrapper around leaky abstraction. And there's so many ways you can go wrong, especially when you apply it to the web.
Definitely. And the idea is, once you start getting those types of feedbacks, you start coding a bit more confidently, because it's kind of like having tests behind you. You know that there is something that's actually checking what's happening. And if I change the query and I forgot to add an index, I'll see those effects immediately. I'll see them and get notified about them and be able to do something about them.
So rather than wait for that report up the stack of this, the app is too slow. I mean, what I find very cool about this, and I'm just looking at some of the screenshots and things, is you're in Studio, you're looking at your code, but highlighted beside it is how this code ran in production from OpenTelemetry data. So you can see that the 50% case took this long, the 95% case, the slowest case, took this long. So you see the variability in that. Like, you're kind of being guided to your problem children.
Exactly. And actually comparing those environments is also really critical. So knowing that, let's say, this area where I'm having major issues in one environment, which is production, is not getting hit at all in my testing environment, for example, would be some other insight. And that's an interesting insight that's kind of cross environment, just because we have the various different contexts.
Right.
So all in all, I think that the one way to see how valuable it is for me was just to turn it off. Because, and you can see that in the screenshot, like on the website, where you kind of see these code lands and highlights all around your code telling you what's going on here. And then the first thing I do is I turn it off, and suddenly you know that it's still there. You just can't see it, because that data we didn't invent. We just analyzed the existing one.
Yeah, so you're immediately there. Now, there seems to be a sort of a schism here between servicing the OpenTelemetry information and the AI part of the equation. I hesitate to even say that, because is it actually a recommendation engine for how to treat it?
So the AI is used to do a lot of things. We're getting a lot of data, and the first things we need to do is make it useful. And data is just a lot of instances. This took this took that. Mm-hmm. But now you need to start to break it down, to cluster it in order to understand the main flows that are going through the system. Then to start understanding changes, what constitutes a change. Production environments look like a very abstract kind of wall where you just scattered paint all over it. It doesn't look like a nice graph where you can say, oh, here is that area where the change happened. In order to kind of start analyzing that, you need to make very advanced kind of data processing to understand which variables are related, for example. So I can't just say this is slow, this is not slow, because maybe it's slow when a lot of users are online.
Right. So that's where all the OpenTelemetry data comes into play.
Yeah. So you need to correlate that data and to start coming to conclusions about what's the root cause, where is the bottleneck, when did this problem happen, and what is it related to? And all of these questions are great questions. That require a lot of heavy lifting or cognitive efforts to answer.
So how does it?
And that's where AI comes into play.
How does it integrate with Visual Studio, for example? Like, what are the kinds of things that a developer can count on?
So regarding Visual Studio, the idea, and we haven't launched our Visual Studio plugin yet. Right now, we have a VS Code plugin, and the Visual Studio plugin is in development. We do support Writer. From JetBrains. But the idea is that it integrates into both the interface of the Visual Studio itself, so you can always click to see what's happening in this area of the code. It integrates into the functions so that you can see highlights if there's something critical to know about a specific area. And it can show you immediate feedback when you're debugging or troubleshooting. So you can take an action and immediately see, okay, this action just happened, and these are the code locations that were triggered by my action. So it's kind of a mapping or a map between the observability and the code.
Yeah.
It's just where the machine learning model really comes into play, is being able to make sure it's associating to the right code. So it's steering you to the right place.
Yeah. It's machine learning helps with a lot of problems. It helps with anomaly detection, prediction, trend analysis, clustering, and also correlating the code to specific issues and metrics.
Yeah, I mean, a number of times I've been handed a performance report on something and said, now go find the code that's causing this and fix it. Those are much more difficult problems. To try and have tools that help you get to the right association, I think, make your life a heck of a lot easier.
Yeah.
You feel like you look in the right place. I don't know if you are. I don't know how often this is wrong and you're pointing in the wrong place, but certainly I've gone and optimized code that made no difference to the problem whatsoever.
Yeah. And there is a problem here because these performance reports tend to miss a lot of the context. So I got so many developers ask me, I saw there's 100% CPU utilization. Is that bad or good? Like, should I be happy that I actually managed to scale things and parallelize them so I'm using all of the CPU? Or am I being inefficient? There are ways to answer that question.
Yeah.
But they require more context. Or somebody is asking me, this process, I see it's taking 40 milliseconds. Great. Is that different from what was happening
good?
before?
Is that bad? Well,
what's the baseline we should address? Is it impacting a synchronous operation and asynchronous operation? What's going on here? And this is exactly that type of context that when handed a performance report, a developer would often shrug because it's very hard to contextualize it and realize what it means.
Sure.
And as a result, we have what we call sometimes these silos called, the performance expert guys who know their Datadog and graphs and whatever tool that they're using and they're great at analyzing that.
Yeah.
But in my mind, this should be democratized by using these types of technologies like ours, like other technologies that are in the market that make it very accessible for developers. So I don't need to know about graphs and N+1 on P95 and on medians and what I can or cannot do about that in order to understand the significance of a data point.
Well, often we have exactly the situation with profilers are complicated enough that you tend to have a team who specializes in using it. But it would be nice to have everything, OpenTelemetry kind of sets us up in a place where we're always telemetering everything. So just to be told, hey, this chunk of code's not particularly fast, but it doesn't run very often, so it doesn't matter. That's fine. Yeah. As the old 40 millisecond one is great. If you're running something once, 40 milliseconds is awesome. If you're running it a billion times, 40 milliseconds is not that good.
Exactly. And you know what? This is something I was talking to someone who actually works in an observability company. Ironic as it is. And he told me, look, I manage a team of developers, and my number one issue is that I see them spending so many cycles just optimizing for the wrong thing. They go and micro-optimize the heck out of a piece of code that gets called once in a blue moon and does this setup process that nobody cares if it takes 40 minutes or 60. Yeah. This other piece of code that's right there, that's kind of every millisecond you add there will have kind of a ripple effect across every microservice in existence because, I don't know, it's decoding some string or something like that. And they don't realize it. So they don't spend an extra thought as they add the only code addition or changes there. So it's that kind of dissonance between, what some people might know about the code, and what everybody should know about the code in order to make confidence.
Good profiling getting you down to here is frequently called code that needs to be faster, that will make a difference in everybody's lives if it goes quicker.
but think about profiling. Profiling is also not continuous. It's something that's usually kind of
it's an interval thing, and it's
you need
based
to
on.
alert.
It's also
It's
constructed
reactive.
tests, so you're often testing against bad data, right? Building good tests is hard too. So it's like, I have highly optimized this for this scenario that will never happen, but boy, it goes fast when that thing that never happens.
Exactly.
Did the name Digma, is that kind of like a play on dogma? Like it's not dogma, it's Digma.
That's a good interpretation. And it's not that far. When I was thinking about the name, I'm Israeli in origin, and the word in Hebrew for paradigm is paradigma. So
Okay.
I just removed the para, and then we got the digma. Because for me, it's kind of changing a parable.
Right.
Wow. That's cool.
This core idea that how your code ran in production always appears beside your code, I'm very much enamored of this. This is a healthy thing. That if you are every time you look at code that's been out in the wild, you also see what happened. That this is what it looks like in the wild. Because just that gardening aspect of, as you're grooming through the code, you could see something that would just draw your attention long enough to make the small optimizations that might make a difference. It doesn't become a big optimization ritual. It just becomes gardening.
Mm-hmm. And I think that it also goes hand in hand with developer responsibilities becoming different than they used to be. So code ownership is growing, and this is something I think we're seeing across the industry. Developers are doing more and owning more. It's no longer a handover process. You mentioned before the QA team from 20 years ago, where it was, okay, I'm done. You guys take it from here. And then it's kind of like, And then they do their QA, ops do their ops, and kind of somehow this package makes its way to production.
Yeah.
So continuous means that everybody's doing a little bit more. And developers today do some QA on their code, right? They're doing testing. They're aware of at least of the deployment aspects of it, so they know how to kind of what resources to require and so on, and where they wish to deploy it, what they need from an authorization or different perspective that are more holistic about their code and how to use it. And as a result, they own it much more. And the question is, how can you as a developer be expected to own your code when you don't have the data to do it? Like, how can I ask you, Richard, it is now your responsibility to own this feature that you developed. This is yours. If this breaks, it's on your head.
Right.
And then on the other hand, the moment you released it, you know nothing about what's going on with it.
How will I know when it broke?
Yeah.
Yeah. So being aware and involved in those things is critical, in my mind, to being.
Yeah. I just love the idea that you're always reminded that your code is being used by others.
Yeah.
Like that's going to keep you in the right headspace.
Certainly.
For sure. And we think about the negative, or we mentioned the negative, but there's a lot of positive feedback as well.
Oh yeah. This is fast. People are using this.
Oh.
I'll give you an example. We one of the things that we added in Digma was finding scaling issues. That's not rocket science, but still something that's hard for somebody to do manually, which is basically correlate, let's say, concurrency with performance and say, you know what, whenever this code is being called with a concurrency of, let's say, 8 requests per second, this is how it performs 2 requests per second. This is how it performs 10, and this is how it performs. And we can start seeing the trend and tell you the scale factor of this code is nice or horrible, or we can say after X amount, there's a lock in there and it breaks down completely.
And it causes problems. Yeah.
And that's okay and important to know as a negative impact. But then we added the positive feedback as well.
People are using this code.
This code slaps. If you actually run this code, it will. It's one of the most performant, scalable areas in the code so far, because you've done your job right. So, in my mind, if you don't also provide positive feedback, it becomes that looking for trouble paradigm
mentality.
again, where I'm not going to glance in there because I'm afraid what I'm going to find. Versus this is actually giving me good feedback about the things that I do, and when I improve things, then I feel good about it because I can see it as well.
So what's next for Digma?
Yeah.
So we're not launched yet. We're going to launch officially in August, but until then, we're running a closed beta. So anybody who's interested in joining the closed beta is more than welcome. We love developer feedback. This is what we're basing our own kind of feature set on. And we'd love to have more developers get their hands on the product and tell us what they like and what they don't.
Awesome.
I've already signed up. I can't wait.
Awesome.
Yeah.
That's great.
Roni, thank you very much. It's a great concept, and I'm looking forward to seeing the execution. It looks great.
Thank you. It was really great being on the show.
You bet.
Yeah. And we'll talk to you next time on .NET Rocks.
.NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a